Hello, Geotech class of 2025. This is going to be a video of soil identification, soil classification, kind of just some tips and tricks on how to do this problem. Um, yeah, so let's dive straight into this. This is an example problem and a soil I engineer myself. So there is going to be a couple things that y'all don't do in class, but it's going to cover everything and more of what you need to know. Just a little bit more in depth of what y'all will get into this semester. And I did that on purpose. Just make sure y'all understand the full concept and do stuff that's harder. So when it comes time for homework or test, you know what to do. So problem statement. The purpose of this assignment is to classify a soil sampled based on sieve analysis and Atterberg limits data by calculating values such as percent retained, percent passing, and coefficients like Cu and Cc. And plotting the grain size distribution on a semi-log graph, we will determine the soil classification using both the USCS and the ASHTO systems. This will help us understand the soil's properties, how it might behave in soil engineering applications. So we're gonna get a graph that looks like this, and we obtained this by performing a soil classification by three different standard methods: ASHTO M145, ASTMD 2487 Table 1, which is also the USCS, and the ASTMD 2487. So I'm gonna get those to those at the bottom here, but um, a couple notable things to point out are the percent passing, sieve size, and in the US standards and in the millimeters. It is really important that, here, let me add this color here, that you know these sizes for this semester. And that's really going to set you up because he is going to expect you to know those. So just get comfortable with them when he first introduces them. So. I want to also mention that we obtained the particle size data by performing sieve analysis as per ASHTO T88 or ASTMD 422. So um, that's how you're going to get it in the lab. Um, there's going to be a couple other columns, let's say on the homework or the test, that he is going to have you fill out. I think there's going to be like um, other columns over here, just kind of expanding on that. It's going to be the cumulative percent retained and the mass retained. And but the only thing you're going to actually need to do the graph down here, which I'm going to get to in a sec, is the percent passing and the sieve size in millimeters. So let's get on to that. So we have this graph here, and I already did it for you because it takes a little while to set up, but once you have it set up good, then it'll really set your problem up nicely um, for what you're going to try to do down below, which is the soil classification part. Um, ASHTO T88 shows a graph with increasing particle size on the x-axis, while ASTMD 2487 shows a graph with decreasing particle size on the x-axis. And why I mention that is because Dr. W and me do it differently. I do it with the percent passing, or sorry, the sieve size on the x-axis, and he does it vice versa. So um, I just want to mention that. Yeah, so when you're graphing this, you can, I like to set this up pretty standard. This is how I set up all my graphs here. Just 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.9, 0.8, 0.7, 0.6, 0.5, and so on. That's just in log form. And then going up here, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to set you up pretty good for the graphs that y'all are going to be doing. And these green lines here, I'll get to in a second, but these black lines also help me out. Dr. W recommends using a straight edge for this assignment, and it's really important because you want to make sure your points line up because it's really going to set up your D10, D30, and D60 for later in soil classification. Um, and I want to comment on the straight line versus smooth lines in the data points. If my data is irregular, versus computer generated smooth lines, it might cause errors in the graph. So you really want to make sure it is as smooth as possible as you can make it. But obviously, um, I couldn't do it. I try to make it as smooth as I could, but usually the in class examples he's gonna have you do, it's gonna be like this, or in my case, it's gonna be like that. So let's move on here to the D10, D60, and D3. So now that you got it all graphed up, you're gonna look for where it goes and meets D10. So that is gonna be in the number 10 subsieve. So that's gonna be right there on the point. I made it super easy for you just for first example. Um, and I also did, as you can notice, on the D30. That isn't really the main point of the problem. Don't expect it to be lined up perfectly like that every single time. I just did that for sake of time and getting more onto the soil classification part because that's the part that's going to take up the most time and has most confusion. So for the D60 point here, you can see that I did not include a point right on the where the six number 60 sieve hits on the line just because I wanted to show y'all what it looks like and that it's not going to be on an exact point. And this is where a straight edge really comes into play just to show where it meets, and that's about 0.78 or 0.79. So that's, it's really rough. I would say that's about good. But that's why it's really important to get the exact guess in there as best you can. Just make sure your soil classification, um, your uniformity coefficient and your curvature coefficient are the most accurate they can be. So let's go down here. And I guess it's the third step you're going to be doing. You're going to be actually calculating your CU, CC, and group index. So the uniformity coefficient is D60 over D10. So I already read that out. That's 0.785 over 0.075. And it comes out to be 10.4667. For the curvature coefficient, D30 squared over D10 times D60. I already wrote that out, and that's going to be 1.06157. So, reaching kind of the middle point of the soil classification part of the problem, you're going to reach the soil classification. So, you're going to be faced with a chart that has the liquid limit on the x-axis and the plasticity index on the y. And so you're going to look at this and go, what do I do? But the liquid limit and the plasticity index are already going to be given to you. So it's as simple as just going. So liquid limit 5. Okay. Or what is it? No, sorry, 20, 20, 20, and going up 5. So it's going to go right on this line. Couple things to note here are that it's going to graph in the CLML and above the A line. He might ask you, is it above or below that A line? I've seen that before. Just something to be aware of. So now that you got those points, you can actually head up here, go to your group index, and fill that out. So the F is going to be the percent passing the 200. The liquid limit is right here, and your plasticity index is going to be right here. And so I already filled that out. It's going to be 0. I'll get to that, what that means in a second. It's also good to write out the gravel, sand, and fines percent from your graph originally, just to help you on this back part of the problem. Um, so now we're gonna start with table 4.8a of ASHTO, classification of soils and soil aggregate mixtures. So one thing you're going to notice is it has two parts right here. This part A and this part B. And you always have to start reading from here and go across. Go across, go across. And what's that going to allow you to do is just cancel out things that you don't need. So up here, everything passes. So I'm going to immediately go like this. Another thing is number 40 sieve. Uh, let's check if we have, oh, sorry about that. Let's check to see if we have 50 max, and we do. So that's good. I'm going to highlight that actually. Do we have 25% max on the number 200? And that is where it fails. So let's go over here. Do we have 51 minimum? Nope. And cross that out. And since this is just three dotted lines, I'm gonna go ahead and just go down to the 35 max. We're gonna go here. So, um, the 35 max, we do have that for the number 200. So let me actually highlight that real quick. And we get down here and it says to go to the liquid limit and plasticity index, and it has a bunch of B's right here. So what you're going to refer to actually, you're going to see table values 4.8b for values. So table 4.8b, ASHTO classification of soils and soil aggregate mixtures. So you're going to go to this part B per se. So instead of doing the entire process again, you're going to skip right down to the liquid limit and plasticity index. And Um, we do have, let me get my highlighter here. We have a 40 max for our liquid limit and 10 max for our plasticity index. So that works out. So that's going to be silty or clay, gravel, and sand. Um, this is going to be a part of the name, but you're not quite done yet. So you're going to get to the gradings down here. So it's going to be just excellent to good for this problem. So excellent is 0 to 4 or 5, and good 10 or 20. It's important to note here also when you're doing the ratings for the soil is that it can never be fair to poor or excellent to good. They can never be one or the other. It has to be excellent to good or fair to poor because um you're dealing with different soils. It can never be poor, and this is because um, of the standards, ASHTO M145-7, but also ASTMD 3282, and it further explains that the group index only should be used to compare soils within the group and not in between groups. That's a really common a mistake that I personally have done, when I came down here, my eyes immediately went excellent to good or fair to poor, and you just want to focus on one or the other. Um, ASHTO M145 Table 1 and 2 shows the performance ratings in general for A1, A2, and A3, and different for A4, A5, A6, and A7. So there's going to be uh just different performances based upon what you pick, and this the most important part is this does not bleed over into this, so it can never be poor. Reiterating that, let's go name our ashto soil. So this is going to be an A dash 2 dash 4 based upon um the group that we chose it in, and this is going to be our group index here, which was 0. Um, we're gonna say it's a silty. Sorry. And then you're gonna put a comma saying rated excellent. And that is all for the naming. Um, so most important part here is the group it's in, the title here, what it is, and make sure to get your GI um right, just to make sure you have that right tag on here. So let's go on to the ASTM standards. It's important, there's three charts mainly, and you want to differentiate in between the two. The ASTMD 2487 figure 1, figure 2, and figure 3. Um, it basically has to do with organics. We don't typically put organic or deal with organics in this class. Um, you can usually smell organics that stink, like rotting wood or paper, and it's better in this class. Um, that Dr. W just said. We're not really dealing with any of the soils that are organic, so we will automatically assume that the finds here are not organic. So based upon that, I chose this chart right here. It's going to be sand. I'm going to actually drag this down. Hold on, just to show you. There's hold on. Yes, actually, let me grab the chart down here just so y'all can get a better look at it. Others really know where to put it. We'll just look back up at it. So it has more um than 12% fines. We're gonna highlight that. And this is where it kind of splits off, the different fines, different classes, and where it was plotted on this chart up above. So remember that we did our liquid limit and plasticity index, and it was set above the A line, right? Not using that in this problem, just reiterating that, and that it was in the CL/ML section. So you can automatically cancel these two out. So it's going to be right here. So I'm going to highlight that. And the SCSM automatically. And so here we get more than 15% gravel, or sorry, less than or more than or equal to 15% gravel. So if we look up here, we have gravel at 17%. So we're gonna pick this bottom one here. I'm gonna do the best to highlight that. Okay. So how that's named is it's really simple. It's just silty, clay, and with gravel. You don't have to include the GI index or anything like that. You just gotta make sure to this showed up the SCSM. Make sure to tag that at the end. Alrighty. So now we're on to our last soil identification or classification chart. This is the USCS standard. And I just want to reiterate, we're not dealing with organics. Um, and so we're just not going to assume anything here is organic. Um, so this is basically like this one, but laid out, the ASTM, but a little bit more complicated, I think, in my opinion. There's just, I don't know, it's set up a little bit weird. So you're gonna start off here, more than 50% retained on the number 200 sieve. Sands. 50% or more, course fraction passes the number 4 sieve. And we're gonna go to the sands with fines, more than 12% fines. And fines classify as ML or MH, and fines classify as CL or CH. So we run into a predicament here that if you look up at our first chart, it's CLML. So we have, as you see here, CL and ML. So what are you going to do? If that happens, usually it's just one, but in my case, we're going to select both. And I'll show you how that plays out in a sec. So that's going to be SN, SC with silty sand and clay sand with a little superscript that shows F, G, and I. In a way you can also check to see that this is right is that the SM and the SC, the group symbol, shows up again. So we're going to have that in our final naming. But before we do that, we're going to check these F, G, and I on both of them. So F, G, and I, so it's right here, G and I. So if the client classifies CML, use dual symbol GC, GM, or SCSN. So they do. So we're gonna go like that. If fines are organic, add with organic fines. We're not gonna assume that's organic, so we're gonna cross that out. So this goes into a long list here. Sands with 5 to 12% fines require dual symbols. So 5 to 12% fines. Um, we fall into the 15%, so we're actually just gonna mark that out. So you have officially done all the naming processes. We just gotta write them down real quick. So this one is gonna be silty, clay, sand with gravel, SC, SN. So that is the setting up and naming process of the soil identification and classification. If you have any further questions, Dr. W's office hours are amazing. I would definitely utilize him as a professor, and he will help you out with anything homework related. I personally spent some time in there learning this concept and many more, but now I understand it and am able to teach y'all. So I'm very blessed to do that, and I hope this video helped y'all out with this process.